What's up guys, this is Youngno. Let's solve this question. In this question, we're looking for the sum of the solutions to the given equation. So why don't we just find the solution first and find the sum later. So let's simplify each side. I'm just gonna simplify the left hand side. Once you distribute 3x, you get 3x squared plus 6x and minus 96. And if you expand that, distribute x, and you get 43x minus 2x squared. I just want to have all the terms on one side. So I'm just going to move all the terms onto the left-hand side. Then you get this equals 0. Then why don't we just collect all the like terms? So quadratic terms, we have 5x squared. And linear terms, we have negative 37x. And we have only one constant term. So we have a quadratic equation. So finding solution to the given equation is nothing but the same thing as finding the solution to this quadratic equation. The remaining part of the job is just to solve this quadratic equation. Okay, here's the question. How do you solve the given quadratic equation? There are two steps. First step is you have to give it a try if it's factorable. If the given quadratic equation can be factored out easily, you're done. You can find the solutions easily. But sometimes it's not really easily factored out. So then you have to give it a try for the second option, which is quadratic formula, which looks really ugly. Since it looks really ugly, you might want to give it a try for factoring first. So let's give it a try. Factor 5 and factor 96. 5 can be factored into 1 times 5. And negative 96, wow, it has a lot of combinations, right? So I don't know, let me give it a try. Negative 96 is negative 3 times 32. So cross multiplication, negative 15 and 32, we're getting 17. We're not done because we're supposed to get negative 37, but we're getting positive 17. Oh my God. Let me just give it another try. 96 is 6 times 16. So I don't know, let me put negative here, then cross multiplication, negative 30 and 16, that's negative 14. No, that's not negative 37. Conclusion. This quadratic equation cannot be easily factored out. It might be factorable, but I don't know. I just don't want to try more. I'm just gonna move on to the second option, quadratic formula. Negative b plus minus square root b squared minus 4ac all the way over 2. Let's do that. Negative b plus minus square root b squared minus 4 times a is 5 and c is negative 96 all the way over. No, I forgot to put a here. This is proper one. So we're supposed to put 2 times a here. These are the solution values to the given quadratic equation. But one good thing for this question is we're not looking for the solutions. We're just looking for the sum of the solutions, right? So I'm just gonna replace all of these ugly expressions as star. So what we have found here is negative 37 is 37 plus minus square root of star over 10. We have found two solutions, plus version and minus version. And we don't need to evaluate the star part because we're looking for sum of the solutions. Then see, the square root of star part will be gone. Collect all terms on top, 37 plus square root of star plus 37 minus square root of star. Then square root of star part will be gone. And we're gonna left with just 237, which is 74, and 10 in the bottom. That is the correct answer, which can be expressed as 7.4, or if you want to simplify it, divide top and bottom by 2, then you get 5 and you get 37 on top. So anything could be the correct answer to this question. But I don't know if this is an easier way to solve this question, but you can solve this question graphically. You might like it. I'm just gonna draw the graph of this one, which is a parabola. I'm just gonna find out where its value is equal to 0. That means I'm gonna find x-intercepts. Y equals 5x squared minus 37x minus 96. Indeed, we have a parabola that opens upward. And what we're looking for here is x-intercept because we want the y value equal to 0. So the first x-intercept is located at negative 2.035, and another x-intercept is here. That's 9.435. We found two solutions, and since we're looking for the sum of them, all you have to do is just add them. 9.435 minus 2.035. Yes, we're ending up with the same number. So in an algebraic way, we ended up with these solutions. They all have the same value, and graphically, I just added the value of two x-intercepts, and we're ending up with the same number. I think graphical approach is way easier for this question, right? Because you might not want to use that ugly looking quadratic formula. So be flexible. Some questions, algebraic way could be much easier, and for some questions, graphical way might be way easier. So be flexible and ready to use any possible methods. Okay, we're done. See you on the next question.